Good morning. Happy Friday. All right. It's been a busy few days. Mostly with me like just continuing to work on this. And it is now 7 days until my the conference talk. So time is starting to get a little bit short, but I'm still feeling confident. I realized last night that I'm at that point where it's time to start like actually thinking about how we're going to really adapt the deep learning algorithm that we created for the streetlight problem to this Pong problem. So let me show you what I have from last time. So if I hit refresh, we have like press enter to start. I press return and use up arrows to sort of play. The ball is turning red because we left in an algorithm that I was using just to determine the ball collision state, and that was it. When I lose, it's just a single. This is a single game. It's not like a race to 10 or anything, and I'm having it log out what happened during that. So this is now the inputs and the outputs. So they're the exact same length wrong, which is, I mean, that's kind of the important thing here. And so my inputs are an array of objects that include the ball location, like the X position of where the ball is, the Y position of where the ball is, the velocity, so how fast is the ball going and in what direction, X, and then the same for Y. Also, the paddle location X and the paddle location Y. I decided not to put in the center of the paddle, but rather just the top left corner of the paddle, which I think should be fine. So my idea is that I kind of want a bot that's going to play as kind of like me, which means it will probably lose compared to the AI, especially since the AI is a pretty standard Pong style AI, which means if the ball is above the paddle, move up. If the ball is below the paddle, move down. So let me go ahead and show you the code for the Pong game in case you're interested. All right, so we start with Pong itself. So we're using P5.js for those of you who were here last time and saw that that's what I was using. I'm using P5 because it's super simple to set up. It's using a canvas and it's decently fast, and I should be able to hook up the AI, well, both the AI and the deep learning algorithm pretty easily. So basically in the setup function, I'm just like creating, okay, well, let's create our canvas and inject that into the appropriate DOM element. We'll create the ball and the paddles and the AI, which itself is super simple. And then we just begin, okay, if we're not started yet, then show this screen. And then after we press return, it switches over to plain. Plain really just means that the ball is moving. We're able to press the up and down for the paddles, and then the ball actually can collide against the ceiling and the left and the right. Also, if the ball is off the screen, then it's game over time. Also, at that point, like as soon as game is over, we record the input. And what that means is, well, actually, record input is happening this entire time. So like every single frame, it records what the state of the ball, what's the state of everything. Miguel, hello, good morning. And so that's kind of like the basics of where this is. Record input. Oh, of course, my VS Code is I don't have like, I think I installed too many extensions and now it doesn't know where to go anymore, or it doesn't like recognize the style of coding, so it can't find it, which is not necessarily the best. But all right, let's go to record. I decided for inputs for the deep learning algorithm, just the ball location, the ball velocity, and the paddle location. I think that's all one would need. I'm going to make the deep learning algorithm be very... I'm trying to limit the number of outputs, so I realized I could also add in the height of the arena and the width of the arena, the location of the enemy opponent's paddle in case it wants to like get a strategy to try to beat it. I don't think I'm gonna do that for right now. I'm just trying to like, hey, if the ball is up here and it's going up, and if we keep the arena the same size, then that, I think that should work for us. Also, I'm not really going for like a perfect deep learning algorithm. I'm going for one that just sort of is good enough for right now. Maybe later in the future we can go for maybe one of the genetic algorithms that we see online so much, and that those ones would go for more like perfect playing. Who knows? We could even like pit that against this algorithm when we get it running. And our outputs, I'm thinking, is going to be a 2-output neural network. So up and down is going to be the neural network, which the 2 outputs is so that way I could have a not moving at all. Because the way I play is sometimes I don't move. Sometimes I just sort of wait until I see what it is and I'm not pressing any buttons. And I kind of want the AI to have that option too. So if it's nothing, then just be nothing. I know this is going to complicate it a little bit because it's not going to be exactly the same as the streetlight problem anymore, but we already have too many inputs for that, so we might as well add one more output. So that's sort of like the basics of what I have game-wise. I do have the code for this up online. It's on GitHub. I can share that with you all, and I might as well add the Twitch start the highlighter because I keep on forgetting to do that. And I can share where that code is. All right. So with that, I think it's time to start figuring out how I want to get these inputs that I have just console logging right now. I want to get them, I need to like create the weights. And the way, I was thinking like a back end. So right now I have this all in an Express server. And so these are just served up via the public, and I can have a path here. So I could say app dot pose to slash. This would be sort of like the record of the game. So the I guess I could just call this an API slash, what is this? Record game, I guess. And then I'm probably going to want some kind of database, but even if I don't, let's say I just print this out. So I console log request.body, and I am response.json. I don't really care about getting this request right now. In the future, we could probably just hook this up. So as soon as we send it in, it starts the entire process and trains the weights, and then maybe even responds with the weights that we want. But for right now, we're just going to console log out. I do realize that with Basic Express, we don't get body parser, so we need to set that up too. Here's what we need. These things. And of course we need to bring that in. So const body parser. So hopefully we should now be able to send a post request to there. I think P5.js actually has that built in. So there's an HTTP post. I think that's exactly what I want. I'm hearing some things downstairs, so I want to make sure that I can, in case anything is loud, I can see that it's happening. Also, what is, oh, stop, please. I was clicking on it randomly, and then it was just covering up the DOM. Not exactly what I wanted. Yeah, I think the microphone is picking up a little bit of music from downstairs. So I'm going to kind of close the door just a little bit. All right. Hopefully that should be a little bit better. So HTTP post URL, JSON, the data, and a callback function. And then we're setting okay, and this is what we're gonna do as soon as it happens. All right, I'm fine with that. Let's go do it. So here we have record input. Where are we? Right here. So at game over, we're then going to record this input. I'm thinking I actually might want to only do this if we won. So what if we do this? We're going to record input all the time. I don't need to console log record, but if we won, we have the text you win, and we also want to send record to server. I'm gonna guess that's obvious. So send record, and then everything else is global because, you know, reasons. So I should be able to just have this down here. All right, HTTP post. So we need the URL. So I guess API. Actually, I'm going to do this trick where it's just starting with the slashes. So that way it will do HTTPS or HTTP depending on whether or not I'm served with HTTP or HTTPS. So this is going to be localhost colon 3000 for right now. Obviously this will have to change if we decide to deploy this. I'm not actually sure I want to deploy this. I could just run it locally when I give the talk. I'm trying to like highlight it, and it's instead of putting XFL on there. Thanks. All right, so then we have to tell it that it's gonna, what kind of data it's gonna be. So that's data type is JSON. So I can start this here. Okay, so the post data, what are we sending? I think I want to just wrap this. So const data equals the record dot inputs and record dot outputs. And then we're going to have a callback function with the result. So I guess in this case we can console.log what the result is, but I don't really think I'm going to care that much, because it's just really that message success. All right, so switch over to here. We should see the message pop up at this location. And the message pop up down here. Oh, right, I have to win. I almost forgot. So I can't force it to lose. Right now, it's actually not that easy to win, because the AI's paddle is only 1 pixel slower than a ball. Oh, that's fun. It's a little bit of lag because I'm recording at the same time. I may have to consider that when I'm streaming live, if I want to like stream using this computer itself, just like I am doing right now. All right, this is. Oop. I may need to force the issue by changing the AI, because it's too good for me right now. All right, let's make the paddle slower. We'll just cheat. Oh wait, we won. Okay, perfect. We have an uncaught error there, so that's great. Also, this filled up. Oh, right, because it's let's close that. Payload too large error. Oh, okay. So now we have another fun problem. That object got too big because we played for too long. So we're gonna need to have some kind of we need to figure out like what to do to keep to not record so often, probably. Right now it's every single frame, which I think is probably a little bit too much. Maybe we should record once every like second. I think it's 60 frames per second. So let's think about that. Let's how would I get timings down? Frame count. I think I remember reading somewhere that the default frame rate is 60 frames per second, but I could be wrong. This is setting it to 30 and then doing something based upon the 30 frame rate. If you go off screen, change the color. Oh, and then switch the frame rate to 10. Oh, interesting. The other thing that I wanted to do is stop, like just fully stop the refreshing, like sending. Maybe I should have like a sent data. And as soon as we send the data, even lowering the frame rate, oh yeah, so if I lowered the frame rate, I would get this problem regardless, because it would still be the number of frames. I would just be able to play perfectly because I would have the same reaction speeds as the AI. I think the frame count. I was hoping that frame rate would allow me. Can I use this to find out what the frame rate is? Hey, where'd it go? I'm wondering if I could use the frame rate to see what the what it is set to. No, I have to set it separately. So I can set it to 60 or I can set it to 30. But it won't like give me what it is by default. I mean, not a huge problem. All right, so what is this? Sent data equals false. Send record is... I don't necessarily want to... Well, I guess here, when this result comes in, sent data... Oh, that will take time, and it'll still send it multiple times. Let's just do this. We'll have send record down there still. In here, make you go away. UN send record. So if not sent data, we're going to send the record. But then we're also going to say sent data equals false. No, true. So that way it will not send that anymore, and we won't get the console log anymore. So that's one of the problems. The other problem is the framework isn't helping us here, but the frame count could. So we could count, we can set the frame rate and then count the number of frames. So frame, see, that's a function. What do you think, 30 or 60? We can do 30 for my poor computer to make sure that I can handle this. And then every 30 frames will be 1 second. So that's when I can record it. So here I can have if frame count modulus 30 is 0. So if you're divisible by 30, then we'll record the input. So once every second. That is a magic number, but hopefully it won't be the worst thing in the world. All right. So we're back to listening again. Where did my game go? Did I lose it? I think I did. Oh, look how slow it is now. But I win. It didn't run. Was there an error? There was. Var error equals new error. Where was my error? I have 3 errors. The server responded with a status of 404, not found. So /API/record game. Oh, well, I should probably update this. So I can update the numbers to make it move a little bit faster, or I could switch it back to 60 frames per second. I'm also thinking that this isn't really quite... Oh, there it goes. So here are inputs. Ball location. We can sort of see how the ball was moving. And we can see what I was doing. So I moved up, moved up for the first second, was standing still, moved up, then moved down, and then won the game. I don't know if this is helpful, because I think this is too few outputs. to like determine when I should be moving up and when I should be moving down. This data might not be good now that I look at it. So I think I need a lot more. Let's try setting it to 60 frames per second, and then we're still going to every 30 frames. Check it. So that way it's every half a second. I should spend more time like actually moving. This is going to end up being too big though, isn't it? Because I'm not winning right away. So I'm thinking I need to do something to cause the AI not to win. Oh, there it goes. So all of these updates now, because it's every half a second, it's still only catching me when I'm moving a little bit of the time. The rest of the time, it's like, no, you don't need to move. What do you think about these inputs and outputs? I don't know enough about this to know whether or not this is going to end up working or if it's just going to end up not being enough data for it to properly train. Because it feels to me that it's going to decide that it wants to just not move more often. No frames lost yet, but I got a little message saying that the encoder was overloaded, which that's fun. Too much movement on the screen, I guess. Or maybe it's because I got this new monitor and so it's physically bigger and has to do more to sort of like scrunch it down. Well, let's I guess I'm okay with trying it with this. And then we'll see what happens. Let's begin setting up what the functions would be. So if we want to train this, we have our inputs and outputs. I'm almost thinking of just saving these as a file now, as just a JSON file, and then we can import them whenever we feel like it. So we could have like a completely separate program that runs our inputs, and then that will spit out the weights. And we can just copy paste. We can just load those in with a require. I think that's what we can do, and then we can just say, hey, let's grab the weights in. Or I'll just put into another file, and we'll script source them. I think that'll work. Okay, so my initial idea was a database, and then it grabs from the database for it. Which probably would be the best way to deal with this. But let's say that we got our weights, we got our inputs, we got our potential outputs. Let's have a new file on the server. I'm gonna take, what will this be? This will be the deep learning. And so this will be the actual, we'll have the functions. And then we'll also have like the main deep learning. So I'm thinking, I don't like index. It's too generic of a word. So I think neural network. All right, what do we have here? We have the inputs coming in, and they want to just automatically start running through this. We might want to also pull up the code that we had from the other one. Here, that is. Oh, but the deep learning functions was out here, so I actually want code at this point. So in chapter 6, we have our streetlight double network. So this is the one that was in the end working. And we can see, okay, we started by generating all of our inputs and outputs. So that's the first thing we'll need to have here is our function, which is the, and we'll be taking in the inputs and the outputs too. I guess I'm gonna need, do I need testing data too? That might be nice. But then I'm not sure I could easily have it automatically work. I'll have to add all that logic in. Let's just try getting this and getting the error as close to 0 as possible, and then we'll add that into the code and see if it plays the game. And that could be our test. So what's the name of this function? This is essentially our neural network. Is it like it houses the entire thing? I'm overthinking it. So we have to have our inputs and our outputs. So we're going to call the neural network with our inputs and our outputs. And I'm thinking we're just going to like slowly console log our way through this, and then see this as it happens. So then in server, we're going to bring that file in. Oh, you can't find it? Wait, where did it go? Oh, I put this into functions. Wrong place. I also then copied immediately afterwards, so I lost my paste buffer. So that was fun. All right, so the U can be empty for right now. You are going to have this neural network, which means you can actually see neural network. So we're going to call neural network. I'm going to pass it request dot body dot inputs. And eventually we're going to grab the end weights from this, and that's what we're going to send back. I'm a little worried that this is going to require too much plane for it to like really work. Also, that did that send? It should have. This should have gone out, run there, sent the inputs to the neural network. And then that should have console logged it out, which it did not. So I'm also thinking of in Pong here, maybe paddles. Let's make the speed of the paddle like 8. That will really handicap the AI. I just want this for like the testing as we like prepare this, then we can do the real data at the very end. Okay, so now we have our inputs and our outputs coming out. So I guess for some reason it didn't restart the server with NodeMon, despite the fact that I had made a change to it, even to server.js. So what can we do? That was such a slow game. We only got one input. Not enough for a real test, but we can play with that. All right, so neural network. So the first thing we get, our data. We have to set our alpha. The hidden size. This is going to be the outputs of the first layer of neural networks, like how many of them. So in the streetlight problem, we had 4 outputs and 3 inputs, and then 1 final prediction. This is going to have 1, 2, 3, 4, 5, 6 inputs. I'm thinking I want to either match the inputs or have like more. So I don't know the reason for having like a hidden size of 4. Like I don't know why we'd want to go up or if we want to go down, but let's make this 7. Then we need to, so this is the first time we need this. We need to create our first weights, which means also we need to have a create random matrix. So a const layer 1 weights equals, I'm going to create random matrix. And we're going to use the hidden size as the width. So that's going to be the outputs. And the inputs as the height. Is that how matrices are normally created, with width being the first one? I kind of want to I want to like experiment with that. So let's see, Python 3. Zeros, if we do something like 3, 2, oh, really? I thought zeros could be used that way. Hold on. The shape, the data type. Oh, it needs to be a tuple. I need to send in a tuple. That's what's the problem. So 3 is down and 2 is width. So it should be height first and width next. So that's interesting. And I have it, I believe, is opposite in these functions here. Oh, you won't take me to it? In deep learning functions, we have create. I have a create random matrix here. It's the width and the height, and it looks like this is the height and the width. Rows, columns. Yeah, I think you're right. So this is going to be the opposite. So our rows, looking at this, so we have this as the width. The width is the columns, so that's hidden size. So I want the inputs first. At least I think that's how it works. All right. You could also maybe look at the solution and see what they had here, which is we're creating this 3 and then the hidden size. So this one, the output, is the second one that's being passed in, and the first one is the number of inputs. So that's the way I'm gonna see this. Is we're gonna start with the number of inputs. So it's gonna be inputs, the first input dot length, and then the number of outputs, which is hidden size. So layer 2 weights. And now we're going to do the same thing, except now it's the opposite. We're going to go from the input for this is the hidden size, and our output is going to be the outputs. How many of those we want. Then we're going to begin iterating. I'm just going to iterate once. And inside of here, we need to calculate the full errors across this entire iteration. So I'm going to call this total errors, and we're going to initialize that to 0. I know that I'm eventually going to want to set these to lets. I guess I might as well do that now. So you're going to be a let, you're going to be a let, and you're going to be a let. Then we're going to iterate through all of the streetlights. So for every single streetlight, we're going to need the inputs and the outputs. And I think that's the only thing we're going to care about in this, because where do we need I here? Just when we're grabbing the current streetlight, and when we're grabbing what the expected result was. And that's it. So this will be the inputs dot for each. We're going to have our current input and the index. So input index. And so this will just loop through once for these. Now we're going to start grabbing, okay, so layer 0 is actually this right here. So I can call this layer 0 to match. Then we're going to sort of break this out. So layer 1 is the first prediction. And we're going to dot together layer 0 and the first weights. So const layer 1 equals, so we're going to ReLU we're going to ReLU dot and so it's going to be layer 0, so that's layer 0 and the layer 1 weights. So that gives us this. Then we're going to get the final prediction. So I kind of see this as just, this is the actual prediction. Now we're going to dot together layer 1, so that's the intermediate prediction, and the layer 2 weights. So this is what we're going to do on the front end. When we have all the weights, we just need to essentially just have our inputs, which is going to be like constantly coming in as the game, and the 2 different sets of weights, and then that'll give us a prediction and we'll go. So it won't be learning, it'll just be doing. The rest of this, however, is going to be training, which is updating the weights to be correct. Thanks. So what do we got? We've got this, we're dotting that together. All right, so now we need to update the error so we know how much error we have across the entire, all the inputs. So we're going to add. So this is going to be total errors equals total errors plus. We're then going to sum. So, because the result of this is going to be an array. So we can sum. I didn't say that. Okay, there we go. Sum the result of I do wonder this every once in a while. Calculating the layer 2 error and the delta, like why don't we do the delta first? Because it's literally the same, and I could just use the delta in the calculation for the total errors. So I'm going to do that. So const our delta. Oh, this has to be like the final delta. And so here we're just going to say layer 2, which I believe all of these are going to be either arrays or matrices. So I do need to get this far so I can console log what the prediction is. And then that means that we need all of these functions, because if I run this, we're going to get errors saying, hey, relu and dot don't exist. Itsy Prague, good morning. Welcome to the stream. So we have these in here functions. So what do we need? Create random matrix. We also need a relu and a dot. And from what we learned with the create random matrix, this needs to be this is the number of rows, and this is the number of columns. So rows, columns. It is night for you. Are you in Europe somewhere? Or it's even more, it's probably even farther away from me than that. Let's see. The other thing we want to do is the test-driven development for this, so that we actually know that the functions are correct. However, we do know that most of these functions, Australia, awesome. Well, welcome, welcome. Let's see. We do, yeah. So we want to create our test too. So we'll take tests, we'll touch deep. I guess this is going to be the deep learning functions spec.js. So we'll also install, so npm install, this will be a dev dependency. We're going to install Mocha and Chai. If we take a look over here, we do have these tests as well. And so we're just going to sort of bring these over. We could copy and paste these if necessary. For some of them, we may realize better ways of doing them. For example, the create random matrix is now going to be the proper create random matrix as opposed to the sort of backwards one we created initially. But in here, we're going to have yeah, I think what I'm going to do is I'm going to bring my Windows computer to the stream. It's super heavy, but I'll see. I probably will have to drive initially, or maybe I'll just like have somebody else store it for me. When I do this entire thing, because I'm not sure that this one computer is going to be able to handle everything. Although I'm not going to have like, multiple versions of VS Code running for that one. If necessary, I'll switch over and just do everything in Vim too to keep it really light. All right, so we're going to get Chai. Then we need to pull in all the functions. We need to set up our assert. What am I making? I am making, well, so I'm learning how to make deep learning neural networks, and I'm making a Pong game, and then I want the deep neural network to learn to play Pong against a more traditional Pong AI. And I'm guessing that the deep learning network will lose against the Pong AI simply because unless like I basically make the Pong AI not as good, which we could definitely do. There's things that we can do to make it stretch both AIs until one of them breaks. And then we have our describes. So we can start by pulling in our canary test here. I like canary tests. It helps me make sure that things are running the way they want to. And we also need our package.json. I'm going to add in a scripts section. That was in test. And we're going to call Mocha. And that should be it, actually. So npm test. No files found called test. Oh wait, is it because I named the function? Okay, so let's try this. Mocha tests. There we go. So we have a few functions in here already. We have create random matrix, the ReLU, and the dot. So we know we need create random matrix, ReLU, dot. So let's start with a create random matrix. Where did that? Here it is. All right, so create random matrix. should create a matrix with random numbers between -1 and 1. So we actually want this to be the number of rows and columns, and which means we're passing in the rows first. And then the columns. All right, so the matrix dot length. So that's how many rows are in there. Should now be rows. Then for each row in the matrix, we need to assert that the length of this so is actually the number of columns. Still don't wrap your head around this learning problem. Like, what is the target variable? How are the actions of the AI dictated if the target variable is the output of the game? Win or lose? Well, the output isn't win or lose. Using vanilla neural network in a typical reinforcement problem is complete novel to me. Although I have seen a similar approach to a somewhat similar problem where someone used such a network to create a Flappy Bird AI. So I'm not thinking, so it's not going to be a binary input for, or like the correct one is not going to be input of did we win or not, but rather were we pressing the up button or the down button? That's what I'm thinking. So for Pong.js here, when we're recording the game, we're handing the ball and the paddles player, and then what key was pressed, which that means the up arrow, the down arrow, or just undefined, nothing at all. And then in record, we're taking the ball and we're storing, okay, the X position, the Y position, then the velocity X, the velocity Y, and then the paddle location X and the paddle location Y. But then the outputs are really going to be what are the keys pressed. So if we're pressing up, it's going to be 1, 0. So like this is going to be the up button. This is going to be the down button. And then obviously if neither of them push, they're both going to be 0. So that's what I'm thinking of. It's not necessarily recording a win or a loss. I'm only actually recording these inputs and sending them to the neural network if it was a win. So I hope, does that make more sense? I'm also like extremely new to this, so I have no idea if this is a good idea or not. I'm worried that I'm not recording enough inputs where I'm moving the paddles. And so because of that, I'm thinking that it's actually going to not really learn properly. And I could increase the number of times that I like record the data, and I have to make sure that I don't run into the problem where it's like too big of an object and therefore can't send in HTTP, which I suppose in future editions I can switch to a socket-based system where it's like as I'm playing, it's sending what's happening down. And then it says, hey, was the game successful? If so, learn on this. But yeah, that's the plan. All right, back to you. All right, so for each row, assert row.length. So matrix.length is the rows, and then each row down, each row length is actually going to be columns, which that might sort of feel a little bit weird, but that's like inside of each row are the columns. Then we're going to loop through the row. So for each of the columns, we're going to get a column. And we're going to assert is above. Oh, that's not right. Okay, is above column -1 and is below 1. So, and we also want to, do we want to make sure it's not 0? I don't know. I may care about that. I may not. So that's going to be our create random matrix. So that's our first goal here. So we'll run our tests, and create random matrix is not a function, which is, so deep learning functions, right? We need to export these. All right, cannot read property length of undefined because it didn't return anything, or it returned undefined. So we can go up here and see where I was actually on it. Oh, we want to see the actual function now. Our deep learning functions. There's actually a cool section for here called outline, where I can actually see where they all are. Create random matrix. And just to be certain, the classic Pong AI just minimizes the difference between its own Y location and the ball location. I mean, probably the real AI for Pong does that. My AI is quite possibly, yeah. I think that's the way to say it. We're just saying, hey, if the ball is above the top of the paddle, press the up button. Otherwise, if the ball is below the bottom of the paddle, press the down button. And that's all it's really doing here. Is it's telling it what button to press. So this AI is not predicting where the ball is going to go. So the hope is that we have the dumb AI that just says ball is here, match the paddle to here. Even if the ball is heading upwards, it's matching this, which means that if the ball is moving faster than the paddle, it's going to lose every time because it's going to be trying to catch up as it's like coming down at a steeper angle. I'm hoping that our deep neural network will say like, hey, it's coming at this really sharp angle, but the position is at the top. And I'm really like, I've learned that when it's up there, I should actually be moving down right now in order to catch it down here. That's what I'm hoping is going to happen. All right, what was I doing? We're back into functions here. So here is our create random matrix. It's just a double for loop right now. And I can actually take you, copy you, paste you in here. The rows and columns, so this is going to change. So the first one is going to be going down the height, which is really the rows. So I'm going to call this row count. So const row width is actually the columns. Let's see, height. I guess that's rows. You're going to be columns. Row.push, we're going to push a random number between -1 and 1 in there. We're going to push the row into the matrix, and then we're going to turn the matrix. So let's see if this works. It does. Okay, so first passing test. Second, what do we need? ReLU is next. And here is... Here's our ReLU test. All right, so should return the same vector with all the negative numbers converted to zeros. I don't really understand why. I mean, I kind of do. We're freezing the weights so they don't change when it's negative, but like the real why, like behind the scenes of why that's bad to have them be have a negative weight, negative predictions, negative inputs going in is a little bit lost to me. I think that I still need to study it a little bit more to like understand it. But the idea is we're going to take a vector here and convert it. So I don't actually know if we have a vector or if we have a matrix right now. I'm thinking we might have a matrix. We'll find out when we try to run this. All right, so this is basically what's going to happen. Save you. Expected undefined to equal that. So in our functions, we also have an implementation that we created on the stream before, which is our ReLU here. And, ooh, that did not, oh, right, because we need to take in the vector. And that causes that to pass. Perfect. Last up, dot. So we're gonna have to create a bunch of dots because NumPy is nice to Python users, to Python programmers. So dot will be able to be used between two vectors, a vector and a matrix, a vector and a scalar, a matrix and a matrix, a matrix and a scalar, a matrix and a vector, and it has slightly different math for each one. But we don't have the luxury of, well, I guess we could, but we're choosing not to overload our dot function, and so we'll just have a bunch of them. So if we think about it, what to do? Let's open that up here and our neural network. Do we actually want a dot, or is this going to be something else? So layer 0 is an array, so it's a vector. Our layer 1 weights is a full matrix. So this actually needs to be a dot vector matrix. Yeah, I think that's what it needs to be. We can take a look at what we had ended up creating here. So we created our weights. Whoa, I don't want to open you. We iterated through. We got the first inputs. Regarding the setting of the negatives to 0, it has a lot to do with non-linearity and the fact that ReLU is a cheap non-linear function, especially in comparison with a sigmoid function, which used to be the standard activation function. So I think that's what I need to learn more, is the non-linearity and the reason why. I'm not sure if the book went, well, I mean, so it did, kind of. It went over and said like, oh yeah, you need it for non-linearity, but it didn't really go into like, I mean, it tried, but I didn't grok it right away. I think there's some other books that I found that might have better explanations for the non-linearity and why I need to care about that. And so like eventually when I get it, it'll be a grand day and I'll be able to like create a video explaining how it works in like my own words, which hopefully will also help somebody who's learning this. All right, so we get our layer 0. This is just the inputs. So we have that here. Then we're grabbing, we're running the neural network. So right, I created a function down here for our neural network, which takes in layer 0, our layer 1 weights, and their layer 2 weights. So we have those. Then I'm going to grab this layer 1 by ReLUing a dot vector matrix. So that's what I actually care about. It's dot vector matrix. And then passing that in layer 0 and layer 1 weights. And then we're going to do another dot vector matrix between layer 1 and the layer 2 weights. And then we can take a look at the prediction and see whether or not we get it or if we crash. So it's dot vector matrix. That's what I care about. And here we're going to have the vector. Oh, wait, stop. And the matrix. And in our specs here, we have to change you to be a dot vector matrix. And now we can go find the spec from over here. Once we have this, once we like created the matrix, it should be, all of these other ones should be correct for testing. So we're going to perform a dot between a vector and a matrix. A dot is a weighted sum. So multiplying each level between the next level and then adding them up as they go. So take our one. So like this first one, the result is going to be as wide as the matrix is. So 1 times 1 plus 2 times 5 plus 3 times 9. So that's 1 plus 10, that's 11, and 3 times 9 is 27. So 11 plus 27 is 38. So that's why we get 38 here. And then 1 times 2 plus 2 times 6 plus 3 times 0 is this. So that's what's happening here, and that's the reason for this. I'm a huge fan of test-driven development, especially with like heavy math stuff like this, because I can really understand what's actually happening, and then actually run this. So undefined to equal that. So we can now grab our dot vector matrix. Here's our dot vector matrix. Now here's what's interesting. Our dot vector matrix is going to be using a transpose. So this also gets a little bit interesting here. So I'll throw this in here, but we have a problem now. We need more functions. So a transpose takes, oh, let's actually just go and grab it now. Now that we know that we need transpose, it's going to take in a matrix. And we also need an actual traditional dot. So this is going to be vector 1 and vector 2. Okay, so we need transpose and dot as well. And so we need those tests. So here's transpose. What that is doing is it's taking a matrix and it's not a rotation. Initially, when I first saw it, I thought it was a rotation. It's not. It is. We're taking the first column of the matrix and making that the first row. And then the second column becomes the second row. So that's a transpose. So we're basically changing the shape of the matrix without losing any of the data. And the reason why we need to do that for our function is because a dot is between two vectors of the same length, which means we can say, now we're going to dot the row with the vector in our dot matrix vector, or our dot vector matrix. So describe transpose, and then we also need our traditional dot, which is one of the first ones we did. Here it is. All right, describe dot, and then we're going to just grab these two vectors, multiply these, and these, add them all together, and then we get just a single number. So I should be getting 3 errors, undefined for all of them. 4 errors, right, because transpose has two tests in them. All right, so let's begin now. Oh, we can't do dot vector matrix until we do transpose and dot, but we can just put them all in at the same time. Here is transpose. we need dot. Bix plays, good morning. And I think, and dot vector matrix, which we already put in here, didn't we? Yeah. So let's see if they all pass now. No, they don't. Okay. 2 failing, no. Vector multiply is not defined. Oh wait, do I need vector multiply too? Where did I? So in dot vector matrix, line 55. So we need vector multiply too. That's what it's telling us. So vector multiply is by a vector 1 and a vector 2. So in our tests here, vector multiply, so we now need to go find those tests. Here's vector multiply. All right, so vector multiply isn't working, so we need to now grab that function and bring it in. Where did I? Oh, here it is. It is the first function we made. And everything is passing now. Perfect. So we want to see whether or not our outputs are going to work, or if everything is just going to crash and burn. So we want to see that first prediction. Well, actually, this is the final prediction. We're not even just doing the first prediction. This is the final prediction of the first round. So let's. We'll kind of play the game and see what happens. We do have to win the game, and I do have it slightly random the start position, which means it might not finish. There it goes. Create random matrix is not defined. Oh no! Where was that? Neural network, line 4. Oh, and I need to bring in these functions. I completely forgot to. All right, so functions like that. So we need create random matrix, and what else? We need relu. So create random matrix, relu, and dot. Dot vector matrix. You've been up since 6:15 this morning. Well, I mean, hopefully it's still the morning, but it sounds like it's more really late for you. So I hope you get sleep soon. Let's see. Let's try this again. I mean, the real thing. Oh, so just nothing at all. No errors. There's errors up here. $500 internal server error, but nothing got logged out. So that's wonderful. So readable stream, uncaught error, not really helpful. Create random matrix is not. Oh, did I forgot to bring that into? I did. Save that. The app crashed. Create random matrix has already been. No, it is there. There it is. Create random matrix. Save. Did I not save properly? Oh, this is a fun way to play with that open, so it sort of moves the screen up and down. That's not cool. Property cannot read property length of undefined. I may have to end the stream soon because I have to get ready for work soon. I am working from home, so that's why I'm able to stream a little bit longer than normal. So functions, line 38. So at transpose, so when we ran our where was it? This is the first run through of line 38 for this. The length, so we could see in transpose, line 38, so matrix with index is less than matrix dot length. Cannot read property length of undefined. So matrix of 0 dot length doesn't exist. So I don't think we must not be sending in a matrix. I can. So there are ways for me to like double verify this. I think what I'm going to want to do is, unfortunately, like leave this on a not great note, because I don't necessarily have the time to actually like figure out the proper debugging for this right this second. But I'm going to work on it. I'm going to continue working on this throughout the weekend. And then on Monday morning, when we do our next stream, I should, like, I'm hoping that I'll have like the full network working. So you can, like, I'll tweet out if I get it up and running. I might even create a video. I don't know. It'll be sort of like fun to see if it actually works, the plan. I'm also gonna have to like create the data, like a sample of data, and start running this through instead of having to play the game each time to begin this process, because that kind of sucks. So that's what I'm gonna end up doing. Let me go ahead and send up the code. So creating the neural network, work in progress, doesn't work properly right now. So I will push that up. And here's all the code. I will share this out with you all again. And if you're watching the VOD, there is a link to this code in the description. All right. But with that, I am going to have to go get ready for work. So thank you everybody for stopping by and taking a look and helping out. I am doing these streams on Monday, Wednesdays, and Fridays. Next week is going to be a conference. That's why I'm doing this. That's Thursday and Friday. Yes, this is open source. That link is to the code where I've got it all. And I'm not using TensorFlow or anything else. I'm sort of trying to do this from scratch if possible. Let's see. Next week is a conference, so I'm only going to be streaming on Monday and Wednesday. And then the conference day on Friday, I'll be streaming at like 10 a.m. or so. Stay tuned to Twitter or YouTube. I'll do an announcement video when I know like exactly what's going to happen and if I'm actually going to be able to stream or if it's just going to be recording a video and then uploading that later. All right. With that, I hope that you all have a great rest of your day or night, depending upon where you are. And I'll see you all next time, which at this moment is going to be Monday at 6:45 a.m. Mountain Time. All right. Thanks and bye.